Hi guys, in this video we are going to be looking at the number system with emphasis being on the real numbers. But before we get into the real numbers, you have to know that in the number system we have two groups of numbers. We have real numbers and we have non-real numbers. In simple terms, we have numbers which are real and those which are not real. So numbers which are not real are numbers like if you maybe find that you have the square root of -2. This number here does not exist. It is a non-real number. If you go to your calculator right now, for example, and punch square root of -2, it won't give you an answer. And the reason is because that number does not exist. It is imaginary. It is not real. So those are your non-real numbers which are imaginary. So whenever you see the square root of a negative number, you must know that that number is not real. It is non-real. Okay, so the other numbers are real numbers. So real numbers are also divided into two groups. We have rational numbers and we have irrational numbers. Let's start with rational numbers. Rational numbers are numbers that can be written as fractions, where both the numerator and denominator are integers. So there are two conditions for a number to be classified as a rational number. Number one, that number can be written as a fraction. We all know what fractions are, right? Fractions are numbers which are on top of each other. An example would be you might have something like 1/2. You have 1 on top and 2 at the bottom. This is what we refer to as a fraction. So if a number can be written as a fraction, that's condition number one. And then condition number two, if both the numerator and the denominator on the fraction are integers, then that number is a rational number. Okay, let me start by defining the numerator. You will all remember that a numerator is the number on a fraction that is on top, like here. This is your numerator, the number on top, and then at the bottom, that's your denominator, right? So that's what we mean by numerator and denominator. So they're saying that the numerator and the numerator and the denominator must be integers. What is an integer? Integers are negative numbers, 0, and positive numbers. So this is what we refer to as integers. You have 0 there, you have -1, you have -2, and then the numbers go. You have 1, you have 2, and then the numbers continue. These are what we refer to as integers. The negative numbers, 0, and the positive numbers, those are integers. Okay, let's come back. We said in order for a number to be classified as a rational number, it must pass two conditions. It must be a fraction and it must have both the numerator and the denominator as fractions. Okay, let's do a few examples here. Or let's work with the 1/2 that we have there. You might be given 1/2 like that, and then they will ask you, is this number a rational number? Then you check condition number one. Is it a fraction? Yes, we have 1 on top, 2 at the bottom, so it is a fraction. Condition number two. Are both the numerator and denominator integers? 1 is an integer, 2 is an integer. Therefore, 1/2 is a rational number. Okay, so let's say we have 5, and then the question will be, is 5 a rational number? Someone would be quick to say no, 5 is not a rational number because it is not a fraction. When we look at the definition says the number can be written as a fraction. Okay, so let's look at 5. What if I say 5 is the same as 5 over 1? 5 over 1 is 5, right? Therefore, I have written 5 as a fraction. So 5 can be written as a fraction. You see? So it has passed condition number 1. Condition number 2 is the numerator and denominator integers. Is 5 an integer? Yes. Is 1 an integer? Yes. Therefore, 5 has passed both conditions. Therefore, it is a rational number. Okay? Then you can also have, let's say, square root of 9, for example. And the question would be, is this a rational number? And then you ask yourself, what is square root of 9? Square root of 9 is equal to 3, right? 3 is a whole number, but it can be written as a fraction, as 3 over 1. And because it can be written as a fraction, right? That's condition number 1 passed. Condition number 2 is numerator and denominator integers. Yes, yes. Therefore, this is a rational number. And that is how you classify rational numbers. Then let's look at irrational numbers. So irrational numbers are the opposite of rational numbers. If a number is not rational, then it is irrational. Okay, so irrational numbers cannot be written as fractions with the numerator and the denominator as an example. With the numerator and denominator as integers, I'm getting ahead of myself. Okay, so let me give you an example. If, let's say, maybe I have 1 over square root of 2. This is a fraction, right? That's condition number 1. Condition number 2, both the numerator and denominator must be integers. 1 is an integer, but this one is not an integer. Therefore, this whole number is not a rational number. Therefore, it is irrational. Then another example, you can have 1 plus the square root of 5, for example, over 4, right? Let's look at there. It's a fraction. That's condition number 1. Then condition number 2. Is the numerator an integer? No. So it has already failed. This number, it's not a rational number. Therefore, it is irrational. And that is how you differentiate between rational numbers and irrational numbers.